let's say we want to find the lateral side surface area, which is what we've been looking at for the cone generated by revolving a line segment given by this, between this about an axis. So guys, when you start these problems out, make sure that you draw a picture out. Okay, so what does this equation look like? Well, we know that it's a line. Okay, it's got a positive slope. It comes out like this. It hits the intercept here. We know that if we plug in 0, we get 0 out. So we know that's a point on the line. We also know that if we plug in 7, okay, we get a height value of 77 thirds. Make sure that you put it as 77 thirds, that we don't put it as the decimal approximation. Okay, now what we're going to do is we're going to use our formula. So let's set up our integral. So we know that that is 2 times pi times the function times the square root of 1 plus the derivative of the function times dx evaluated between our two endpoints. So let's just go make sure that we wrote that out right. 2 times pi times the function. Oop, did I not put the square in there? I didn't. See? Always make sure you write down your formulas right. Okay, so we got this guy. Now what are we going to do? Well, we need to find f prime here. So let's go ahead and figure that out. So I'll do that in blue. So f prime of x is 11 thirds, which means that implies that f prime of x squared is equal to 121 over 9. You won't be able to reduce this if you can't reduce this. Okay, so we're going to go ahead and plug that in there. So what we've got here is the integral from 0 to 7. I'll pull out the 2 pi. There's no reason to having it in there. Now f is 11 thirds x. Okay, square root of 1 plus 121 over 9 dx. So that is 2 pi from 0 to 7. Okay, this is going to be a number here, so that's pretty nice. So this is going to be 11 thirds times x times the square root of 9 ninths. So this will be 130 over 9. So what we should do is try to go ahead and see if 130 can be factored out. Okay, now we can either sit here and play around with our calculator with this a little bit. So 130, it's not divisible by 4. It is not divisible by 9, of course. It is not divisible by 16 if it's not divisible by 4, obviously. And then, of course, it's not divisible by 25. It is not divisible by 36. Okay, 49? Nope. We only have to go up to halfway, right? So, it's clearly not divisible by 64. Okay, so 130 can't break this guy down any more than it already is. So, this will be equal to 2 pi times the integral from 0 to 7 of, now this is going to be square root of 130 over 3. So this will be, I'm going to rewrite this as 11 thirds times square root of 130 over 3 times x dx. Right? Now, let's see here. Our bottom is 9. Our top is 22 pi times the square root of 130. This times this times this times this over 9. Pretty ugly there, right? Times the integral 0 to 7 of x dx. So this will be 22 pi times the square root of 130 over 9, okay, times x squared over 2 evaluated between 0 and 7. Well, at 0, there's nothing, so we'll just plug in the 7. So that'll be 49 over 2. So this is 22 times 49 times pi times the square root of 130 over 18. Now, well, I could just cancel this 2 with this and just make this 11. That might be a little bit faster. So, what do I have left? I've got 11 times 49, which is 539, times pi times the square root of 130 all over 9. Okay, and of course, this isn't going to be a factor. So this is as a decimal. Let me go ahead and calculate this guy out here. I think I'm getting approximately 2,145.20008. It says round to the nearest tenth. So that will be this guy right here. So let's go ahead and check that out as a solution. So I've got 2145.2. It says that we did it right. Now, okay. So that's one approach to doing this. Okay, now that's the approach you need to take. That's what we're working on. Okay, we're not. The idea is not just to get a solution, but to get it using some calculus. Okay, because any computer could tell you that solution. So don't try to make this easier on yourself and just do the old geometry, because if you do, you're gonna end up with an issue. Okay, now let me show you how we could have solved this, or how we can check this at least without using calculus. Okay, so this is the check. Well, what I've got is I have a cone whose height value is 7, whose radius value is 77 thirds, like this. And we know that the surface area is going to be equal to the following. We know we have a surface area. Where did it go? Right here. It's pi times r times L. Okay. So that's going to be equal to pi times r times L, which is the square root of 49 plus 77 thirds squared. If you do this out, guys, it's going to give you the same value that you had before. And you might say, well, let's just use this. Why go through all that hassle? Well, this was a nice cone. Okay. As soon as we get into problems where this guy is not a cone, as soon as we get into problems where it's just some ugly function, and we're revolving this guy around the axis, you're going to have a lot of problems if you just try to do the cone formula.